Hi class, this week we have talked about the different ways that we can represent relations and how we can tell whether or not one of these relations is a function. We have focused on four different topics. In this case, we looked at graphs, ordered pairs, tables, and mapping diagrams. So on your graphic organizer, we're going to review how to identify the domain, range, and whether or not these are a function, given these different scenarios. If we look at the set of ordered pairs, we want to make sure that we list the domain in order from least to greatest. So in this case, that would be -1, 0, and 2. The range, again, is your y values. So we will list the y values in order from least to greatest. That would be 2, 5, and 7. In order to determine whether or not this set of ordered pairs is a function, you want to look at the x values. We have -1, 0, and 2. Since these x values do not repeat, this set of ordered pairs is a function. For a table, the process is very similar. We are going to list the ordered pairs in order from least to greatest, and we do not want to repeat any of the x values. So again, in this case, our domain should be listed as -2, 0, and 3. You will notice that I did not write the 3 twice, even though it is repeated in the table. The range, again, is your y values, and we want to write that in order from least to greatest. So I will start with -4, 1, 2, and 6. As I have stated in this table, you will notice that there are 2 3's. Since we have 2 3's, we have a repeating x value, which means that this is not a function. In our mapping diagram, we want to remember that the x values are on the left and the y values are on the right. So the domain of this function is -7, 0, and 3. The range of this function is 1 and 2. If you look at the x column and you notice the arrows from each one of those x values, you will notice there is only one arrow from -7, one arrow from 0, and one arrow from 3. This means that our x values do not repeat, and therefore, yes, this is a function. As for our graphs, this is the separate case scenario from the other three. When we are writing the domain and range for a graph, a continuous graph in this case, meaning that it is joined with a curve, we have to scan the graph from left to right for the domain and from bottom to top for the range. So if I look at my x value furthest to the left and my x value furthest to the right, we will use our interval notation to write the domain. In this case, my circle begins at -4 on the left-hand side, and the x values go all the way over to a +1 on the right-hand side. Remember, you will use brackets around this interval to show that those numbers are included as a part of the domain and range. For the range, we will scan the graph from the bottom to the top. In this case, you will notice the y value at the bottom of the circle is -2, and the y value at the top of the circle is +3. Again, we are using brackets around that domain and range to show that those numbers are included in the points on the graph. Now, in order to determine whether or not this graph is a function, we have to use something called the vertical line test. And if I was to draw a vertical line through this circle, you will notice that it will touch the top of the circle and the bottom of the circle in that same vertical line. If the vertical line touches your graph more than once at any location, this is not a function. We will save the last equations circled to fill in during class together. Otherwise, you should have a completed graphic organizer and bring this back to class the next time that we meet.